So we're going to prove theorem 3-4 later in the course. So now we're going to take it as, we're going to accept it as true, and we're going to need it to prove some of these other theorems. So we'll start out with proving theorem 3-5 or 3.5, 3-5, converse of alternate interior angles theorem. All right, so if we're given that angle 4 is congruent to angle 6, right? That's our given. So we can start with that, right? Angle 4 is congruent to angle 6. Next, we can say that we can go a couple different ways. We can say angle 4 and angle 2 are congruent, because then 6 and 2 will be corresponding. Or we can do 6 and 8, right? So I'll do 4 and 2. So I'll say for statement 2, angle 4 is congruent to angle 2 because of the vertical angles theorem. All right, and once we know that those two angles are congruent, let me just start marking these in. So we knew this and this, now we know this. So now that 2 and 6 are congruent, we can use the converse of corresponding angles theorem. So we can say that lines L and, or actually, forgot a step there. So I can say that angle 6 is congruent with angle 2 because of the transitive property. All right, and so because 6 and 2 are both congruent to the same angle, they must be congruent to each other. And finally, now I can say that L is parallel to M because of the converse of corresponding angles theorem. All right, next theorem 3-6, converse of same side interior angle postulate. So now we're given that these two angles 3 and 6 are supplementary, right? So they're on the same side of the transversal and interior in between the two lines that we're trying to prove parallel. And so they're supplementary, and we want to prove that that makes the lines parallel. Okay, so we'll start with our givens. Angle 3 and angle 6 are supplementary. All right, and that's a given. All right, and then the second step. So we once again have various routes we could take with this. But I'm going to say that, okay, well, 6 and 7 are also supplementary because they're a linear pair. So I'm going to say angle 7 and angle 6 are supplementary. And the reason linear pair postulate. All right. And now we can use the congruent supplements theorem, right, to say that, okay, well, 3 and 7 are both supplementary to the same angle, so they must be congruent. So angle 3 must be congruent with angle 7 because of the congruent supplements theorem. All right, so now that I know that angle 3 and angle 7 are congruent, those are corresponding angles, so I can say that, okay, line L is parallel with line M because those corresponding angles are congruent, right? So that's the converse of corresponding angles theorem. And keep in mind that I could have done the same thing with, instead of 6 and 7, I could have done 5 and 6. And then once I proved that 5 and 3 were congruent, then I could have used the converse of alternate interior angles theorem, right? So once again, various routes you can take in proving these. And finally, theorem 3-7, converse of alternate exterior angles theorem. We're given angle 1 is congruent to angle 7, right? So angle 1 is congruent to angle 7. It's given. All right. So given that information, I can say that, okay, well, 1 is congruent with angle 3, right? Vertical pair. So angle 1 is congruent with angle 3 by the vertical angles theorem. Okay. And then by the transitive property, since angle 7 and angle 3 are both congruent to angle 1, we can say that angle 7 is congruent to angle 3. Oops. Transitive property. It's a funny R. All right. And so angle 3 and angle 7 are congruent, and now those are corresponding angles. So we can say that since the corresponding angles are congruent, that means that line L is parallel with line M by the converse of corresponding angles theorem. All right, so once again, there's various routes we could have taken with that, but those are the proofs for 3-5 through 3-7.